Hello students, MoNaCo here. In our last video for Unit 1, we're talking about the last little piece of matter, something that we've seen many times throughout our education, 7th, 8th, 9th, 10th grade. You've done it in all your science classes. We're focused on page 3031 of your packet. You're going to learn how to measure for and calculate density, which hopefully you already know how to do, but we'll make some connections to the meaning of density. We're going to start out with what mass versus weight is, because density's equation is density equals mass divided by volume. So mass is how much matter something has. It's like how many atoms are in it. Okay. Weight depends on gravity, but both are directly proportional. As mass increases, weight increases, because as you have more atoms, you are going to weigh more. We really only work with mass in chemistry class, but we might say go weigh this or go mass this. They're often used by many scientists here on Earth interchangeably. The correct terminology is to use mass. We have the same mass whether we're here in outer space or on the moon because we have the same number of atoms in us. I didn't lose an arm to become lighter on the moon. I still have my arm. The atoms in my arm are still there. The moon on the gravity on the moon is just less, so I don't weigh as much. Volume definitions, amount of space an object takes up. For liquids, we always want to use a graduated cylinder. Be careful, measure the meniscus, determine what the increments are, and always use one estimated digit. So usually to the 10th decimal place when you're measuring liquids. For a regular solid, you want to measure the dimensions and use length, width, height formula. And in this case, you're going to be more accurate and more precise, going to 2 decimal places on your length, width, and height. So your calculation for density will be volume, will be 2 decimal places. For irregular solids, we got to be a little bit more tricky. We got to use our crafty techniques. We got to use the water displacement method like we did our marbles in our lab last week. Now, density is overall, it's an extensive property of matter. It can be used to identify unknowns, and it depends about the mass in a given space. It's the ratio of mass to volume. The formula from our reference table T is density equals mass divided by volume. And a great example of what this means is box A versus box B. Which one is more dense? Explain your answer. Box A is more dense. Why? It has more atoms in it than box B does, and box A and box B are the same size. It's got more stuff packed into it. That is your explanation. Please write it down. Now, some additional notes on density is that density for water is 1 gram per milliliter, or 1 gram per centimeter cubed, because 1 milliliter equals 1 centimeter cubed. They're equivalent units. 1 centimeter cubed just shows you got it from length times width times height. 1 milliliter shows that you got it by using a graduated cylinder. You'll always have to measure the volume. Either you're going to use displacement or length times width times height. Now I want you to listen to my voice and put some additional bullets in this area. Okay, I'm not going to put them on the screen. You're going to listen to me and put them down. That's how I know you're actually paying attention to your homework videos. Density can be used to identify an unknown, solid, liquid, or gas. For example, I had a student last year, and as a matter of fact, the year before that, came to me with what he said was a gold chain. He said, this is a gold chain I bought, mister. I want to know if it's pure gold. How much money? I got it for 20 bucks. I want to know if I got a good deal or if I got ripped off. And I said, well, let's think about it. Let's go and measure the volume of your golden chain using the displacement volume method versus the mass of your chain. We'll make sure it's nice and dry. We'll put it on the scale and we'll calculate density equals mass divided by volume. Then we're going to go into our reference tables and find the density of pure gold. And when we compare the two numbers, if they match, it means your chain is pure gold. If they don't match, it means your chain is not pure gold. It doesn't mean there isn't any gold in it. It just means it's not pure gold like it's stamped, because the chain had a little stamp on it that said 24K pure, to imply that the chain was made out of pure gold. Well, The story turns out that this child did not have a pure gold necklace.